Hi and welcome to the last video on the modulus function. This one it finally deals with some of the questions you get in the textbook. Now, I haven't seen any of these types of questions in any exam, past exam or practice exam. I don't think I've ever seen it in any SACs or any tests or anything like that. It could come up. That's the reality of Year 12. I don't know what's on the exam. It could come up, but I don't know if it's all that likely. I think it's still good to know anyway, because it combines a couple of things that we do in Year 12. So some of them will be relevant for now, some of them a little bit later. And I'm sorry if you can hear a little bit of background noise. The drama room's going crazy on me. Anyway, I've got x, absolute value of x minus 1 plus the absolute value of x plus 3. What I'm going to do is I'm going to draw them individually on this set axis here. So x minus 1 is this graph just here, and those two lines have two different equations. This one is x minus 1, and this one is going to be the negative value of that, so negative x plus 1, which I've got labelled just there. Similarly with this one, x plus 3 is this line here, and so this line here will be the negative value of that, so it'll be negative x minus 3. Now what I want to focus on are these pivotal points here, because this is where the two graphs change. This is where the lines change, and if we're going to add these two graphs together, what I'm essentially going to do is I'm going to add each line together. So I'm going to find out what x is, so I'm going to give a value of x, say x is 1, and then probably x is 2 is a better example, and then I'm going to find out what that is here, and I'm going to add it with what this is here. Essentially, I'm going to add the two y values together. So when x is 2, I'm going to add this one with this one. I'm going to add this one with this one. I'm going to add this one with this one, this one with this one. Now that's a concept that we'll come back to later in the year. You don't really need to understand a lot of it now, but it's kind of helpful if you sort of get where I'm going. So what I'm going to do is I'm going to look at these two pivotal points here. That one is x equals 1, because that's what I had from that graph. And this one is x is negative 3. Now, what I'm going to do is I'm going to ask myself, what is the value, what is the equation right to the right of this point, to the left of this point, and on this point? And I've got this written down here. So for x minus 1, the absolute value of x minus 1, when it's greater than 1, I've got this, x minus 1. When it's equal to 1, I've got 0. And when it's less than 1, I've got this line here. Similarly with the x plus 3 graph, and you can see that there. Okay, and then what I want to do is I want to say, well, before negative 3, because that's this one here, like before this line here, I'm going to add this line with this line. Okay, and so what I get is I end up getting negative x plus 1, which is this line, added with negative x minus 3. I haven't put in the add, but because it disappears. I'm actually literally going to add all of these values together, and I get negative 2x minus 2, which you can't see. Sorry, there it is. I get negative 2x minus 2. When I add let's jump to the right hand side now. I'm going to add this one here, x minus 1 with x plus 3. I end up getting 2x plus 2. Okay, and then finally I'm going to do the bit in between. I'm going to add this line here with this line here. And for that I end up getting just a number of negative x plus 1. I just get the number of 4, negative x plus 1 plus x plus 3. So what happens is that I end up getting these three equations for the different parts. But when x is less than negative 3, I get this equation. When x is between negative 3 and 1, I get this equation. And when x is greater than 1, I get this equation here. Now, how that looks on a graph is not that difficult actually. We just need to draw three different parts of a graph. This is called a hybrid function, and we'll probably have a look at this a little bit more later on. So if I just draw this down here, my very rough axis, when x is less than negative 3, which is there, I've got negative 2x minus 2. Well, that graph would, negative 2x minus 2 would start down there somewhere and go up here. It would have an intercept at negative 1, so it would look something like that, and it would keep going up there forever. I'm just not going to go up there because I'm going to draw over that. Okay, and then if I look at when x is greater than 1, which is over here, it's going to have the same kind of shape, 2x plus 2. That's where 2 would be. that's going to go up like that forever. And then finally, in between -3 and 1, it's equal to 4. So that line there is equal to 4. I can find out all of these points here by subbing in x equals 1 into this equation. X equals 1 into here, and I'll get 2 plus 2, which is 4. It's going to be 1, 4. And this one here is going to be -3, and -3, that's positive 6 minus 2, which is 4. Okay, so this graph looks like this, this, and then this. It's got a flat bottom. Now, again, I haven't seen a lot of these in past exams. I haven't seen them in many places. In fact, the only place I've seen them is in the textbook. It's not a terrible question, but they're just not all that common. Hopefully you've been able to understand this, and I would encourage you to do a couple in the textbook just so you get your head around them, because I think it kind of helps with your graphing and algebra, and does pull things together. So thanks for listening. If you've got any questions about the modulus, please ask me.